is a subset of the universal. Therefore, F will definitely be a subset of the universal. And this simple analogy is what we know, what is known as logical reasoning. Another example of this Converse case, because we have the implications, and the implication is what I've been able to demonstrate here. This F is not connecting the universal directly, it's connecting N. So the implication here is that since F is a subset of N and N is a subset of the universal, automatically F will be a subset of the universal, and that is the implication. If we talk about the Converse case, then what we are trying to say is that using an implies symbol, which is denoted by this, when A implies B, when A implies B, then the converse case will definitely be B implies A, or A going this way implies this. So B implies A. So that is what is known as converse case. Then the equivalence. When we say the equivalence, if A is equal to B, implies that B will definitely be equals to A, and that is the equivalence. With this notation and the symbols that have been demonstrated here, we'll be able to justify the logical reasoning. Example 3. Write the following statement as implication using implies where appropriate. It is shown below in figure 1.3. In the figure 1.3, we can see that no person is perfect. No quadrilateral has 4 sides. All teachers like holidays. Let X be a person. Let X be a person. Then it implies that X is not perfect. Let X be a person, then it implies that X is not perfect. That is the converse case of that. Then the other case is that let Y be a quadrilateral. Implies that Y has no 5 sides. Y has no 5 sides. Then the last case, you have all teachers like holiday. Let Q be all teachers. Let Q be all teachers. Then it implies that Q does, or let Q, then Q do not like holidays. So here it is obvious that we have a statement and we have a converse case. We have a statement, we have a converse case. We have a statement and we have the converse case. And that is the principle of logical reasoning. So let's talk about conjunction, disjunction. So we want to talk about the aspect of conjunction, disjunction. let's consider figure 1.4a. In the figure 1.4a, we have, is it true to say x squared equals to 25 implies that x equals to 5? If not, correct the statement. If you look at this statement, which is x squared equals to 25, it is obvious that when square crosses to the other side of the bridge, you have a plus or minus square root of the value. So automatically you are having x equals to plus or minus square root of 25, which now gives us plus or minus 5. And the statement x equals to 5 implies that x equals to plus 5. The sentence implication of this statement is that it does not incorporate x equals to minus 5. Therefore, the statement is not true, because the sentence implication is that the statement x equals to 5 is not true, since it does not incorporate plus or minus 5, which should be the statement. So therefore, this is not x squared equals to 25, which implies that x equals to 5 is not true. In the figure 1.46, to analyze the concept of our conjunction and disjunction. When we say conjunction, we are talking about bringing two or more entities together with the use of and, while disjunction has to do with the splitting with the use of or. So if you have this statement, this is a universal set, people who live in FCT, while D is doctors, G, people who wear glasses. If you want to draw this Venn diagram, because in logical reasoning we make use of Venn diagram. We make use of Venn diagram. So in the Venn diagram we have this and we have this, where D is for this first one and G is for the second one. S1 can definitely be people who are medical doctors or people who are doctors and who wear glasses. People, S1, let S1 be people who are doctors and wear glasses. S2, let it be people who are doctors or who do not wear glasses, or either or both. In the S1 case justifies conjunction. S1 case justifies conjunction, and the conjunction is justified by the use of and, where in the logical reasoning and can be denoted by this symbol, which we call intersection, or this V, which is a symbolic logic symbol. Is a symbolic logic symbol. Then or is denoted by this, which is called union, or the symbolic logic symbol this. In the first case, S1, people who are doctors and wear glasses. So it can be denoted by this, which also implies that it could also be D, V, like a cap, then G. And if you want to represent this on the Venn diagram, it will simply be like this, where you have your universal to be this, then you have your G, then you have your D. So here, this is the point where we are talking about in the S1 case. In the S2 case, we also have the Venn diagram, but what you have here is different because of the fact that you have the disjunction. It is not linked, unlike the case of the S1 where it is linked. So here you have this and this. This is your D and this is your G. And since you have the people who are doctors who do not wear glasses, automatically you have your D union G. Or it also implies that D, G. And if you want to represent this on a Venn diagram, having this side will definitely be shaded. So that is the answer to the two cases, demonstrating conjunction where you have it linked and disjunction where you have it separated. Let's talk about the truth tables for the representation above.